Modeling fractions using concrete materials and drawings helps students develop an understanding of fractions. Three common fraction models are the area models, set models, and linear models. And if you're looking for a virtual set, there are a lot of different virtual sets that you can find for free. One great resource, well, there's GeoGebra is one good resource, but another one is Didex. They deal with actual manipulatives, but they do have some virtual ones as well that are free to use. And here's some the ones they have. But let's suppose these two trapezoids stacked on top of each other represents one whole unit. Then a triangle would be what fraction of that unit. So the idea is, if you want to try to figure out what the fraction is, we need to figure out how many ways can I break this shape dip into triangles. So it looks like I can form, there's 3 triangles on top, and I can make 3 more triangles on the bottom. So that's going to be 6 triangles overall. I can break that unit into 6 triangles. And one of them, it represents the triangle. So that triangle represents 1/6 of the original unit. If I have this hexagon and I want to figure out the combination of a parallelogram and triangle, it looks like I can break that shape into 2 pieces. So the hexagon and triangle makes up 1/2 of the original shape. All right, and this one. A little bit tricky. So in this case, let's go ahead and divide this. This is going to come out evenly. So let's go ahead and divide this into triangle pieces. And I think all these break up into triangles. Okay. So the original shape, 1, 2, 3, 4, 5, 6, 7, could be broken into 8 pieces. And 3 of those pieces make up the trapezoid. So the trapezoid makes up 3/8 of the shape. In a set model, a collection of objects represents the whole unit, and a subset of the collection represents the fractional part of the whole. And they can be real objects like coins, or counters, or square tiles, or anything else you can think of. Well, here is an array of squares, and a rectangle is drawn around some of them, and a triangle around some of the others. So what fraction of the blue squares are inside the rectangle? So to answer that, we need to figure out how many of the squares are there overall, and then how many squares are in the rectangle. So there are, looks like 5 rows of squares, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So that would mean there are 50 squares overall. And that would be my denominator. As for the rectangle, it's going to be, there are 1, 2, 3, 4, and 1, 2, 3, 4, 5. So 4 times 5, 20 of them are inside the rectangle. And that reduces to 2/5. What fraction of the blue squares are inside the triangle? Well, we already got the 50. As for the triangle itself, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 1/5. And what fraction of the blue squares are inside both? Well, that would be, here, let's highlight that. That would be these ones here. So again, there are 50 squares overall, and it looks like that's highlighted would be, the highlighted squares would be the 6. and that would reduce to 3/25. All right, and in a linear model, a length represents the whole unit where the whole unit is divided into fractional parts of the whole. And in terms of virtual manipulatives, you have interlocking fraction bars, there are fraction strips, there's Cuisenaire rods. You can also use line segments or number lines. So if I want to draw a number and use a dot to represent each of those fractions, well, let's start off 1/4. I can go ahead and use this one in GeoGebra. To represent 1/4, the idea is you make sure your denominator is in fourths, and then 1/4 would be right there. For 2/3, there's 2/3. And then 3/8, there's 3. I need to divide it, put the denominator in eighths. So 3/8 would be right over there. So if we're going to draw the number line, like for 1/4, basically you know where your 0 and 1 is. You break it into, your denominator tells you how many pieces to break it into, and then put a dot at the appropriate place. So 1/4 would be about there. 2/3, I would break it into thirds, and I put a dot at the second tick mark. And then 3/8. So you're breaking the halves, quarters, and then eighths. 3/8 would be about there.